All right. Um, so last time we discussed the review of real numbers and their properties, and some basic rules of algebra in state of except especially for fractions. You know, a lot of people got problems in fractions. Uh, Everybody knows how to add, how to mm, subtract, how to multiply, how to divide fractions, but when they do the problems, they always make mistakes. So let me just do one example of adding fractions. So in this example here, we have two fractions, x over 10 and 2x over 5. So when you have two fractions to add or subtract, you need to have the same denominator to do it. Uh, if you do not have the same denominator, then you have to make them the same. So the first thing is to find the least common denominator, LCD. So I don't know why. Okay. So what they do is you um, you factor each denominator. Okay, like 10 in the first fraction. So you can factor as 2 and 5. And the second denominator is 5. There's nothing you can factor. And so then the LCD is just 2 times 5. Okay. Uh, later we're going to do more examples, some fractions. You're going to see that. Then you see how we find the least common denominator in more complicated problems. But in this case, it's just 10. Then you rewrite each fraction by using the least common denominator. So we don't have to change the first fraction is already 10, the denominator. So x over 10. But the second, the fraction is just 5. So we need to multiply 2 to make 10. But at the same time, we do not want to change the problem. So we need to multiply 2 on the top. And that will make 4x over 10 for the second term. Now we get same denominator that we can add. We just add the numerators. We get x plus 4x, which is 5x. And then you can simplify it by canceling 5 uh, on the top and at the bottom. You get x over 2. Any questions? Is it good?
Yes, sir.
Yes.
Okay.
Yes, sir.
Okay. All right. Great. So we're done with P.1, section 1. So let's just start section 2. All right. Okay. Okay, section 2. So that'll be exponents and the radicals. Okay. I'm sure you learned this before, but let me just you know um, review it, do it over to make sure everybody is good at it. Okay. So we're gonna start from integer exponents. So there are two things, exponents and radicals. We're gonna do it one by one. So let's talk about integer exponents and start from a simple example of evaluating expressions. So for part A, we need to find the square of -5. So in this time we have a parenthesis. So that means you multiply -5 by itself, and we got positive 25. Two negatives makes positive. In part B, we got a negative of 5 squared. So this time you should do the exponent first. Remember, there is an order in operations in this expression. So you do 5 by 5 first, and then you multiply by -1. So at the end, you get a -25. There's only one negative. So there's a difference whether you have the parentheses or not. So you should be very careful about it. And that's why people always get the wrong answer when they use calculator. They forget to put parentheses. Any questions? Uh, Anybody has any questions?
No, sir.
Okay, so
Sir.
not very complicated. Okay, in part C, we do another one, 2 times 2 to the fourth. So we use the properties of exponents when you have the same base. We call it 2 base and 4 exponent. So we add the exponents when you multiply 2 exponential expressions with the same base. So if you don't write anything in the exponent, that means it's 1. So the first number 2 it just has exponent for 1. Any problem? So
No.
okay, and then you just add 1 to 4, so you get 5. So the answer is 2 to 5, and if you multiply it out, you get 32. Part D. 4 to the 4 over 4 to 6. When you divide the 2 exponential expressions with the same base, you subtract the exponents. So just subtract 4 and 6, you got the negative 2. So we got a negative exponent. That means we should put the number in the denominator. You got a fraction. So it becomes 1 over 4 to the 2. Or 4 squared. So that's 1 over 16. That's what it means by negative exponents. All right. It's good. So can I go to the next page? Ask me questions just anytime. All right. No question. Next page. Let's do another one. Okay. Evaluate algebraic expressions when x equal to 4. So this time we need to evaluate these 2 functions or expressions and plug in 4 to get to see what the actual number is. In the first question or problem, we got negative x to negative 2. So you do not do the calculation to start. Instead, you should use the properties of exponents to simplify the expression or rewrite in another form so you can carry out the performation, the calculation. So whenever you have a negative exponent, you should put in the denominator. So in this case, we get negative 1 over x squared. And you don't have to worry about the negative sign in front. Okay, that always goes to the last. Okay, and then you can plug in 4 for x. You get negative 1 over 4 squared, which is negative 1 over 16. Again, you do 4 squared first. And the negative always comes the last. Okay, so that's part A. Part B, we need to evaluate 1/4 of negative x to the 4th. So we got the parentheses here. That means you multiply negative x 4 times by itself. So at the end, you can get positive. 4 negatives multiply to become a positive. So you can simplify this thing as 1/4 times x to the 4th. And then you can plug in for x. So we get 1/4 times 4 to the 4th. If you do the multiplication, you get 1 over 4 times 256. And okay, let's see. Okay. Did I do it right? I think it's not 56. I think it's 64. Okay, I need to change that. Okay, I don't know why I put 56. 256 divided by 4 should be 64. Okay, sorry about that. Any questions? Okay, next. Let's do more examples of integer exponents. We're going to do a lot of examples in this section because these things are pretty tricky sometimes. Okay, so in the next example, we use the properties of exponents to simplify each expression. All right, so we need to simplify each problem, and each one has multiplication or square, except for problem B. So in the first example, part A, we got negative 2x, negative 2y cubed times negative x to the fourth y. Okay. And the way to do this multiplication is you just separate um, each part of this problem based on the variable. Okay, for example, you're going to multiply negative 2 by negative 1, the constants. You're going to multiply x to negative 2 by x to the fourth, and the y cubed by y. Okay, just do each part. So we got positive 2, x negative 2, and x to the 4. Multiply, you get negative 2 plus 4 are the exponents. So that's 2 x squared. And the y cubed times y is just y to the fourth if you add and 1 in the exponents. So the final answer is 2x squared y to the fourth. And this is how you do this kind of complicated problems. Just separate each part. Problem B, we need to evaluate the zeros power of 4a squared b cubed. And this problem is especially simple if you know how to do it, because any number, if you raise to 0 power, it gives 1. All right? So, no brainer. C, negative 5z cubed times z squared. Okay, again, we need to separate each part. This time, we're going to separate the negative 5z by negative 5 and z. When we cube negative 5z, that means we cube each part of negative 5z. So we need to cube negative 5 and cube z. So we got negative 5 cubed times z squared. Negative 5 cubed is just negative 125 if you multiply out. Z cubed times z squared, you add the two exponents. 3 plus 2 equals 5, so that's z to the 5. So the answer is negative 1 to the 5, z to the 5. Some people got some problem with the speaker or something, some echo, some noise. All right, part D. This time we have let me see. I'm going to turn off the microphone or something, you know, if I see it. I think Janan, maybe Maurice. I'm going to mute that. Let me see. Or you can mute yourself. So let me just mute that. All right. So that's the problem. Okay, it's good now. All right. So in part D, we need to take the square of this fraction or rational expression. 3x to the fourth over x squared, y squared. So we need to simplify this expression first inside and then square. Don't just do the square to start. Okay, so we know that we got x to the fourth and x squared, you know, at some time that divide each other. So we just subtract the exponents on 2, okay, for the x part. So we get 3x squared over y squared. There's nothing why we can do, okay? And then we can square it. Again, you know, you have to square each part in this expression. So we got 3 squared times x squared to the square over y squared to the square. And at the end, you get the 9x to the fourth and y to the fourth. You know, when you square x squared, you multiply the exponents 2 and 2, you get the 4. For the same reason, when you square y squared, you multiply the exponents 2 and 2, you get 4. Is it clear? Any questions in this part? All right. Next. Okay. Let's do one more thing about this simplification or rewrite with positive exponents. So we got some negative exponents that we need to rewrite by positive exponents, which is more convenient in most cases. So in part A, x to negative 1, that one is pretty simple. It's just 1 over x. Okay. So you put in the denominator, but then you don't have to write 1 in the exponent. So that's just 1 over x. Part B, 1 over 3x negative squared. So this time we got two things in the denominator, 3 and x negative 2. You don't have to do anything with the 3 because the negative exponents is just on the x. So what do? You flip it to the top and change the sign. It's like you flip it to the bottom, in the first example. You can always do the opposite thing. If you have a negative exponent in the denominator, you can flip it on the top and change the sign of the exponent. Okay, so every time when you have exponential expression, you want to move to the from top to bottom or from bottom to top. You just change the sign of the exponent. So then we got x squared on the top. So that's 1 times x squared, and we should get x squared over 3. I don't know why I wrote 5. Okay. Part C. This one is a little more complicated. We got a bunch of things on the top and at the bottom. So we got a 12a cubed times b to the negative 4 over 4a negative 2b at the bottom. So we just do it part by part. Okay, so 12 over 4. So we got the 3. At the same time, we can move the terms to the top or at the bottom. For example, we have b to the negative 4 on the top. We can move it to the bottom, and it becomes b to the 4. Change the sign of the exponent. For the same reason, for a to the negative 2 at the bottom, if you move to the top, it becomes a squared. So again, change the sign of exponent. Then we can multiply a cube by a squared to a to the 5. You add 3 and 2, remember? And the b times b to the 4 is also b to the 5 if you add 1 to 4. So the answer at the end is just 3 a to the 5 over b to the 5. So let's see part D. This time we got a negative exponent, for the whole thing of 3x squared over y. This probably do it in different ways. You can put the whole thing in the denominator and then simplify it. Or you can just start from the negative exponent and use the roots of exponents to distribute this negative to each exponent. Okay, so you got 3 to the negative 2, x squared to the negative 2, and y to the negative 2. Okay, that's how it works for the exponents. And then, you can simplify x squared to the negative 2 by multiply 2 and negative 2. You get negative 4. So we got 3 negative 2 times x to the negative 4 over y to the negative 2. And then, just like we did before, you just move things around top and bottom. 3 negative 2, you can move to the bottom, get a 3 squared. X to the negative 4, you can move to the bottom also to get the x to the 4th. And y to the negative 2 at the bottom goes to the top and becomes y squared. So simplify a little bit. 3 squared is 9, so you get y squared over 9, x to the 4th at the end. So that's the answer. Any questions? So these things can get a little confused sometimes.
So would you flip like on D? You see how
Yeah,
you got y subtract y negative 2? So will
uh,
you just flip that like?
yeah,
Cause I've been seeing like I see if you have like a exponent fraction,
yeah.
like you flip the opposite sign. So that what you do? You just flip the whole problem.
Yes, this problem can do it in different ways. The way I do is just distribute the exponent to each
Yeah.
part and then flip. But you can flip it first and then do it.
Okay.
So
I just, cause I just seen that like as you was teaching, I just seen like several other problems like that. Every time you had an exponent, you'll flip the sign.
yeah. If you
Okay.
move, if you move from the top to the bottom or bottom to the top, you change the sign of the exponent. That's the rule.
Okay.
All right.
Yes,
Any
sir.
other questions? Okay. Any other questions? No question. Let's just go to the next page. Okay. Okay. So let's just use some exponents in scientific notation. Okay. Sometimes we get the really large numbers like the uh, distance from the Earth to the Sun. Okay, that's a huge number, or the weight of the Earth. You don't want to write the decimals, the whole number in the you know, digits. Instead, you want to write in the short notation, and the scientific notation is just using exponents to write those big numbers or extremely small numbers. For example, the mass of an atom or the radius of a molecule or something. Those are extremely small numbers. And you don't want to write a bunch of zeros, in decimal. Instead, you want to write in a short notation by using the exponents, and we use 10. So let's just see how we use that 10 as the base to do the problem. So for the first example, write 45,850 in scientific notation. So the way to do it is you just start from the back. So just suppose you put a point at the end of 0, okay? Then that's what it is. That's what the number is. It didn't change anything. And then you move the decimal point to the left to 4 places, 1, 2, 3, 4, and then it becomes 4.85, isn't it? If you move the decimal point at the right, left, 4 places.
Wait, what did you get? Wouldn't it be 4.58?
Oh yeah, I'm sorry. Yeah, I got a bunch of errors. I don't know why. It must be, that should be 5/8. Yes, I'm sorry. 10 times 10 to the fourth. I have to create all of those small things. I just got a little confused, when I prepared those slides. Sorry about it. You probably have already found quite a bit. Okay. I'm going to create those things and post in Blackboard as I already did. Okay. I already posted in point and the other slides. Whenever I finish a section, I'm going to post it in Blackboard, so you can take a look, and hopefully we're gonna get the video saved that you can watch it, or you can download it from your computer. All right. So that's the first example, and then uh, you know let's do the other way. Okay. Suppose we have a number in scientific notation and we want to convert it back to decimal notation. So this time we got a negative 9.36 times 10 to the negative 6. Okay, so this time you have to move the move move the decimal point to the left, 6 times. Because the negative exponent is 6, that means essentially the number is extremely small. So what you do is, if you write it step by step, you can put a bunch of zeros instead of 9 after the negative sign. Okay, so for example, write negative 0.36 like this, and then you can move the decimal point to the left. Okay, 6 places. So at the end, what you get is negative point 0.00000936. So that's how you do it. Another example, 1.345 times 10 squared. You got positive exponent, then you move the decimal point to the right 2 places. Obviously, this time you get a 134.5, isn't it? So these are two examples. And sometimes, it is very useful to evaluate some expressions with large and small numbers at the same time, like in the third example here. We need to multiply three numbers. The first number is pretty large, and the second number is pretty small, and the third one is also large. So instead of dealing with those zeros, you are going to rewrite each number in scientific notation, and then you just deal with the exponents, which is much easier. So just do the same thing as we did, for the same number. I don't know how I read it. I'm sorry. Maybe 24 billion or something. So suppose just you have decimal point at the end of this number. So then you move the decimal point to the left 10 places, and then you get 2.5, 2.4, and then times 10 to 10 because you move 10 times, 10 places. Similarly, you move the decimal point 7 times, 7 places in the second number to the right. So you got 1.2, and then the exponent is negative 7. So 1.2 times 10 to the negative 7. And for the third number, you do it similarly. You move the decimal point from the end to the left 5 times, and you got 3 or 3.0. Times 10 to the 5. Okay, so it is positive exponent. You move to the left. Okay, so then you just multiply the numbers by numbers, and the exponents just group together. So 2.4 times 1.2 times 3, you're gonna get 8.6. So hopefully this time I didn't get it wrong. And then the exponent, the product, 10 to 10 times 10 to the negative 7 times 10 to the 5. You just add all the three exponents. So 10 plus negative 7 plus 5. So if you do that, you are going to get 8. Okay, so the final
So
answer is, yeah.
so how do you get the exponents at the end?
10, just add all the exponents. You
No,
got
I'm saying
10.
like, yeah, that's what I'm saying. How do you get the exponents? Because the number doesn't have exponents. That's what I'm trying to see. Like, where did you, you know what I'm saying, add the exponents in there?
10 minus 7 plus 5. So are you talking about the first step or the last step?
The example, it says like 24 some, but in
Yeah.
the example at first, it doesn't have any exponents. So at the bottom, it has exponents. So how did you get the exponents in the value?
We just do the same thing as we did in the first two examples. Like in the first example, you got the 45,850. So you put the decimal point after the 0, and then move the decimal point 4 places to the left.
Oh, okay, so
You
you get exponent by how many places you move
yeah,
the decimal. Okay,
yeah.
all right, that's
You do
all I
the
need to know.
you do the same thing for the last problem, 24 students. You just add the decimal point at the end and then move it to the left. This time you need to move 10 times, and then get 2.4 times 10 to 10. So is it clear?
Yes, sir.
Okay, any other questions? Okay, so that's scientific notation. Okay. So that's all about the exponents I want to talk about, and then we're going to do radicals. Okay, radical is another thing that people not very comfortable about it, and there are a bunch of rules for the radicals that we need to know. So let's talk about the radicals and their properties. To start from some easy examples, how to simplify radicals. You know. So let's just evaluate the expression involving radicals. Problem A, square root of 36. That's equal to 6 because 6 squared equal to 36. So whenever you have a square root number, that means you need to find another number. When you square it, you get the number in the radical, under the radical. That's what it means by this square root, isn't it? Okay, so that's part A. Part B, this time we got a negative of square root of 36. Again, you do the square root first, and negative always comes the last. So yeah, you do the square root of 36, so you get 6, and then you multiply negative 1, you get negative 6. Okay. Part C, this time we are talking about the cube root of 125 over 64. So that means we need to find the number. When you cube the number, you should get 125 over 64. And it turns out the answer is 504. When you multiply 504 3 times by itself, you're going to get a 5 cube or a 4 cube, and that gives you 125 over 64, which is the number under the radical. So the answer is 504. Any questions at this point? So this is basically what it means by radicals. Part D, we need to find the fifth radical of negative 32. Okay, so that means we need to find the number when you multiply by that number by itself 5 times, you usually get negative 32. And this turns out to be negative 2. You multiply negative 2 5 times by itself, you get negative 32. So one more thing is about the notation. Okay, that like in part C, cube root and fifth root. You always see this number, outside the radical sign on the top. There's something like this, left, top left. That means the root. So part D, this time we need to find the fourth root of negative 81. So you need to find the number when you multiply this number by itself 4 times, you get negative 81. Turns out that that's not a real number. You cannot find the number that multiply by itself to get negative 81 4 times. Multiply 4 times to get a negative number. Because for any real number, when you multiply it by itself 4 times, you always get positive. So no real number raised to the fourth power produces negative 81. So that's this one. Any questions? So we
No, sir.
okay. So I guess we're gonna stop here. It's already 1:49. We're gonna continue on Monday, and hopefully we're gonna finish this section on Monday. All right. So any other questions before we end the session? So I hope the recording works and everything just goes on the right track. And we have one more minute left. You can ask me one question maybe, or otherwise I'm going to end the session. And I guess we'll stop here and you have a good weekend. It's already 1:50 now.